students, in the previous lecture we have studied about elementary row operations and partial pivoting scheme. And this in this lecture we will study about we will take an example to solve the system of linear equations by partial pivoting technique. So let's see, that is the first equation containing four unknowns x1, x2, x3 and x4. So that is second, third and fourth. These four equations along with four unknowns are given, and we are going to solve this system by partial pivoting technique. First of all, we will write this system in matrix form, writing all those coefficients and this matrix, and writing those xi's and column vector, and this is obviously B. So that is in the form Ax is equal to B. Now secondly, we will take augmented matrix. What is augmented matrix? Augmented matrix is the combination of this matrix A and this matrix B. So that is matrix A, and this last one is matrix B, denoted by A/B. So take the augmented matrix, and we are following partial pivoting. So in partial pivoting we will see that the first non-zero element of first row is 4, the first non-zero element of second row is 8, third row is 12 and fourth row is -8. So we will consider that row which contains the largest number in the first place, and that is 12. So 12 is the largest of all those numbers, all those elements. So make this whole row 1. It means that we need to interchange row 1 and row 3. So interchanging row 1 and row 3, we will get this third row in the first row and this first row in the third row. So that is the first step in partial pivoting, that select that row with largest pivot element, and that is 12. Now secondly, we will make this element 1 for our convenience, not important but not necessarily important, but for our convenience make this element 1. So how could we make this element 1? By multiplying this whole row by 1 by 12. So multiplying row 1 by 12 to make this element 1. So that will become 1, that will become -1, that will become -16 by 12, and -16 by 12 and decimal notation will be given to you people. That will become 29 by 12, and that will become -2.1 by 12. So in this slide we see that the first row has been multiplied by 1 by 12 to get all those numbers. Now after making this first element 1, the second thing is to make all these elements 0 below this one. We should make this element 0, this element 0 and that element 0. So in order to perform this operation, in order to make these elements 0, 8, 4, -8, we need to multiply row 1 by 8 and then subtract it from row 2. So R2 minus 8 R1, multiplying R1 with 8 and subtract it from row 2, we will get these numbers. Manually write row 2 here, and in the second row multiplying row 1 by 8 and then subtract these two to get this answer. Now thirdly, we need to make this element 0. So how could we make this element 0? Multiply row 1 by 4. Just look at this. Multiply row 1 by 4 and subtract it from row 3. Whenever you multiply this row 1 by 4, this number by 4, and subtract it from 4, so that will become 0, and all those elements will be followed in this sense. So Secondly, you can manually do this operation in the side work. Write row 3 from here, and multiplying row 1 by 4, multiply this whole row 1 by 4 over there, and then subtract both of them to get this answer. The answer will be written in row 3. Now the last one is, we need to make this element 0. So how could we make this element 0? Multiply row 1 by 8 and add it with minus 8. 8 minus 8 will become 0. So multiplying row 1 by 8 and add it with row 4 to get 0, and all those numbers are obtained by using this operation, r4 plus r8 row 1. Now thirdly, just look at this second column. We are following partial pivoting. Remember that, partial pivoting. In partial pivoting, first of all, we have observed the largest element and that row, the first row. Now in second case, whenever you observe the largest element, make that largest element 1 and the rest of the elements 0. So that's those two steps have been performed. Now secondly, in the second column, we need to observe the largest element in partial pivoting. So what is the largest element in this column? That is 25. 25 is the largest element in this column. So interchange this row with the second row, interchanging row 2 and row 4. So that is row 2, row 4 will become row 2, and row 2 will become row 4, and make this element 1. As I told you before, make this element 1. How could you make this element 1? By multiplying this whole row, this row 2, by 1 by 25. So multiplying row 2 by 1 by 25, that will become 1, that will become minus 1.427, that will become 2.213, and that will become 0.36. Now after that, make below elements in this column, below this 1, make these two elements 0. This element is already 0, so we need to make this element 0 only. How could we make this element 0? Multiply row 2 by 5 and subtract it from row 4. So multiply row 2 by 5 and subtract it from row 4, we will get this whole answer. This answer is written in row 4. Now thirdly, look at this third column. The maximum number in this column is 9.799. So 9.799 will be written in the third row. I mean that interchanging row 3 and row 4. So that were row 4, which is now row 3, and this was row 3, which is now row 4. We have interchanged these two because this is the largest number in this whole column. Now make this largest number 1 by multiplying this whole row by 1 by 9.799. So we have multiplied row 3 by 1 by 9.799, so that will become 1, that will become this number, and that will become this number. Now make below element, below this 1, make this element 0. How could we make this element 0? Multiply this row by 2.332 and subtract it from this row 4. So we have multiplied row 3 by 2.332 and subtract it from row 4 to get here 0. So that is, you see that this is the main diagonal of this matrix, and below this main diagonal all these elements become 0. Now this is this matrix in upper matrix notation. Now the process has been completed, and you can make this element 1 as well. This is not necessary, but you can make this element 1. So dividing this whole row, multiplying this whole row by 1 by 0.523. So whenever you multiply this row by 0.523, that will become 1, and that is the same 0.523, that will become also 1. Now we will use back substitution to. Now we see that this column, this whole column are the coefficients of x1, these are the coefficients of x2, these are the coefficients of x3, these are the coefficients of x4, and these are the values in B. So using back substitution means starting from the last row, these all the coefficients of x4. So from last row, from row number 4, 1 into x4, because 1 is the coefficient of x4 here, so 1 into x4 is equal to 1. 1 into x4 is equal to 1, so it means that x4 is equal to 1. And going back towards third row, row number 3 implies 1 into x3, because this is the coefficient of x3. 1 into x3 minus 1.368 into x4, because these are the coefficient of x4, is equal to 0.633, and now we see that x4 is 1, so put here x4 is equal to 1 and multiply it with this thing and convert these numbers towards that side to get x3 is equal to this thing. So x3 is 2.001, which is nearly equal to 2. So x3 is 2. Now row number 2 implies, this is row number 2, this is the coefficient of x2. So 1 into x2 minus 1.427 into x3 plus 2.213 into x4 is equal to 0.36. Now putting the values of x3 and x4 from previous calculation, you see we have replaced x3 by 2, this is x3, and replacing x4 by 1, this is x4, and calculating this equation, calculate the last result to get the value of x2, which is 1. So x2 is 1. And row number 1 implies, this is the coefficient of x1. So 1 into x1 minus 1 into x2 minus 1.333 into x3 plus 2.417 into x4 is equal to minus 0.175. Now putting the values of x2 obtained before, the value of x2 is 1, the value of x3 is 2, and the value of x4 is 1. So now calculating this equation for x1 to get x1 is equal to 1.074. So this is the value for x1, that is for x2, this is for x3, and this is for x4, which is actually the solution of this system of equations. So this is the process to be followed in partial pivoting technique to obtain the solution of system of non-linear equations.